Today video we will try to learn BBS of isolated footing. Okay, so first of all we will look on footing plan. So this is footing plan in which you seen combined footing, isolated column footing. So yeah, so if we zoom it, that is CF2 means combined footing number 2, and then at F3 footing number 3. So F was denoted for a isolated footing and CF for combined footing. Okay. So now if we look onto footing schedule. So if you look into footing schedule, F1 is its dimension 8 feet multiplied by 8 feet and have a thickness of 15 inches. Only have a bottom reinforcement 4 number bar at the rate of 6 inches center to center, short direction as well as long direction. Okay, so these are 6 isolated footing and 4 combined footing in the footing plane we see earlier. So we will calculate reinforcement for F1. So first of all understand how it's look like. First of all I will understand. Okay, so it means this is a footing of F1 of 8 by 8 feet dimension. So first bar is placed like this, and the second bar will be placed like that, that it have a 6 inches distance between all these uh, are placed after 6 inches. Okay, like that. Yes. So all bar placed in this direction. So now bar will be placed in this direction, black color. Okay. So what its section look like? If someone see you that draw section from this side, so if we look on from section AA, if we see the footing from standing on you can say right side of the footing, so it would look like this. You will see an 8 foot height lengthy footing having thickness of 15 inches. Yes, this crease base will look like this. It will go up to thickness and then total length. Okay, and black color like dotted bars. Okay, so it is for clear understanding. If you look out from this side, the same 15 inches thickness footing will be shown, but this time black bar will be looked in long side and green bar look like single bars. Okay, so now let's look how to calculate reinforcement for this footing. So this is the overall a template for bar bending schedule. So you have a serial number, descriptions. You can also add sub description numbers, how many numbers of footing isolated footing are. So four isolated footing in that footing plan. So what is the diag bar? Use length, that in how much length the footing will be, the reinforcement will be used. Spacing between two bars, number of bars used and divided by spacing plus 1 is will get number of bars. Then what is the one um, length of one bar? For example, if you see this is length of one bar. Exactly in that direction, this is the length of one bar. Okay, so then we also have we will see from here um, number 4 at the rate of 6 inches. Okay, so it's also for use length is uh, we can say this is the use. If we calculating this sidebar, for example, if we are calculating green bars, so use length will be the tangent to the perpendicular to the length of bar. Okay, so 8 feet. This is square, so you can take 8 feet, but it's for when you have different dimension. Okay, we will inshallah calculate in our upcoming sessions. Okay, so use length is 8 feet. uh, spacing is 6 inches. Okay, so 6 inches divided by 12 for converting into feet, so 0.5 feet. So how you will calculate? So use length divided by, okay, close it, and then add 1. Okay, so total of 17 bar we used. Okay, now what is the length of one bar? So how you calculate? This is the length of one bar. It's equal to total length into 8 feet minus concrete cover minus concrete one, and then plus thickness of thickness of um, footing minus concrete wall minus concrete wall, exact either. Okay, so 8 feet for a straight bar we will take 2 inches, so 2 inch from one side, 2 inch from so 4 is the concrete wall. Okay, now we add thickness of bar on both sides, so 15 inch plus 15 inch 30 inch. So this is the thickness of bar and concrete cover from both sides, so minus 2 plus 2 4 plus 4 8, 8 divided by 12. Okay, maybe you will understand the best how I calculated this. Okay, so 9.5 is the length of bar. Okay, so we calculated main item. Now we just need to multiply all these for total length. How many total length are you? So we will multiply numbers of footings, multiply to total number of bars, how many bars are using, and one length of one bar. So we get total number of bars. Okay, now come to the unit weight. How you calculate unit weight of numbers of bars? For millimeters, the formula will be changed. For number of, this is formula for number of bars. Okay, and so you will formula is that you multiply square of die of bar divided by 2.204 divided by 22, 24, I think 24, yes, 24. Okay, total weight, so just multiply by unit total length to unit weight, you will get total weight for transfer bar of M1. So both the dimensions are the same, so you just select all and copy and then paste it. Okay, so for F1 you need, if you sum both, so it means you need 390 feet, 390 kgs for 4 F1. So for finding one F1 you need just divided by 4, so 97.7 kg for one F1.